Hey there, Algebra 1 students. This is Mr. Wilsey. In this video, we're going to be looking at review problems number 21 to 35 in the EOC practice set. So hopefully you've already tried these problems, that you've locked in your answer choices, and this video is just to check to see that you are on the right track with these problems. Alright, so let's go ahead and start on number 21. Which scatterplot best represents a negative linear relationship between the variables x and y? Now I hope that it's pretty clear that the answer choice is A, because the points lie on a straight line, which means that it's a linear relationship, and it has a negative slope, which means that it is a negative relationship. Now none of the other answer choices make this very clear. Answer choice D is also kind of negative because as x goes up, y goes down, but the points do not lie along a straight line, so it cannot possibly be a linear relationship. So the correct answer here is A. 22. A lawn can be mowed at an average rate of 44 square feet per minute, which is the closest to this rate in square yards per second. I hope that this screams out to you that we need to use train tracks. Choo-choo! I know how much everybody loves train tracks. So let's figure out how to set this up. We want to convert from 44 square feet per minute. So the way to plug that into train tracks is 44 feet squared per minute. Okay? Now we want to convert to square yards, so yard squared per second. Okay? Now, how in the world are we going to do this? Well, we need to recall a conversion factor that is going to help us go from feet to yards. Well, 3 feet is 1 yard. I hope that you can pull that out of your brain pretty easily. So, how do we plug that into train tracks? Well, 3 feet needs to go on the bottom in order to cancel out the feet at the top. 1 yard goes on the top over here. Now, we have a problem because we have feet squared on the top, but only feet on the bottom, so they don't perfectly cancel each other out. The way to fix that is to take this entire conversion and to square it. Okay? Take that entire conversion factor and square it. That will make this into feet squared so that it will cancel out perfectly with that feet squared. And it will leave us with yard squared on top, which is what we want. Now, finally, we need to convert from minutes to seconds. The conversion you should pull out of your head for that is 60 seconds equals 1 minute. And what do we put where? Let's see. In order to cancel out minutes on the bottom over here, we need to have 1 minute on the top, 60 seconds on the bottom over here, so that minutes will properly cancel out. Okay, now how in the world do we plug this into our calculator? Well, what this is really saying is 44 times 1 squared times 1, all divided by 1 minute, so 1 times 3 squared times 60. Now all of these 1's we can just get rid of, right, because multiplying by 1 doesn't affect anything. And then 3 squared is the same thing as 9. So this is really the calculation that train tracks is telling us to do. 44 divided by 9 times 60. So 44 divided by 9 times 60 is this fraction. Let's convert it into a decimal. 0.08. And which answer choice does that correspond to? Letter G. So the answer is 0.08 yards squared per second. Number 23. Which expression is equivalent to the square root of 2x squared raised to the 4th power? Now this is kind of a difficult one to grasp, I think, but imagine this. Imagine if we were asked this simpler question. Square root of 2x squared, what happens if we square that? Well, remember that this square root is the opposite of squaring. They are inverse operations, so they cancel each other out. So this would be simply 2x squared, right? It's simply whatever is inside the radical. But we're not raising to the second power. We're raising to the fourth power. So how does that change things? Well, raising to the fourth power is the same thing as raising to the second power twice. Do you see that? So when we do this the first time, we're left with 2x squared. But we still have to deal with this extra squaring. So what that means is we need to take all of this and square it again. Well, how do we find 2x squared squared? Well, remember that this square out here gets attached to the 2 and also gets attached to the x squared. So the 2 squared gives 4, and the x squared gives x to the fourth power, right? Because you're multiplying the exponents there, 2 times 2. So 4x to the fourth. Which answer choice is that? B. Number 24, bring it on. The function a equals pi times d squared divided by 4 shows the relationship between the area of a circle and its diameter, d. Now we want to find which of these 4 graphs best represents the relationship. Now the key here is to notice that the diameter is squared. So this function, it looks complicated, but it can really be boiled down to this relationship here. Y equals x squared. They're both going to basically have the same overall shape. Now, do you remember what y equals x squared looks like? What that graph looks like? Hopefully you remember that it is... Hopefully you remember that it has the shape of a parabola. Whee! Whee! That, kind of a bowl shape. Now, which of these graphs best represents that parabola shape? Well, answer choice F. Of course, F is only half of the parabola, right? So I hope that that problem wasn't too bad. Number 25. So we have a table here showing us the number of cans of different types of food that were donated. And we're going to select one can from all of these thousands of cans. And we want to know what is the probability that the can that we select will contain fruit or sauce. So how in the world do we do that? Well, first thing we need to know is how many cans of fruit and cans of sauce are there. So the way I'm going to write that is number of fruit cans, and then we're going to add to that the number of sauce cans. Okay, so 1,359 plus 580, so 1,939. That is the total number of fruit and sauce cans. 1,939. Now, we want to know next how many total number of cans we have. So to do that, just add all 4 of these numbers up, and the number that you get should be 5757. Total number of cans. So the way to find the probability that the can that we select will be either fruit or sauce is to simply take this fraction, 1,939 divided by 5,757. So if you do that calculation, 1,939 divided by 5,757. Okay, duh. Thank you, TI Inspire. Take that guy, turn it into a decimal. So 0.34. I'm going to round that. 0.34. About 0.34. Which answer choices that correspond to? C. So what this is really saying is that you have about a 34% chance of selecting either fruit or sauce. Number 26. Here is another problem in which we have to write a linear function from a table of values. Now recall the way to do this. First of all, figure out how much does the function change by. Let's see, it goes up by 3, up by 3, up by 3. And each time x goes up by 1. So that means that the rate of change, the slope of this linear function, is going to be 3 divided by 1, which is positive 3. That's actually enough to determine what the function is. Do you see which one it's going to be? Okay, so let's finish this out. In order to find the y-intercept of our function, we need to know if x is 0, what is the value of the function. So we need to go backwards 1 for x, and that means we need to go backwards 3. So we need to subtract 3. So that means that negative 2 minus 3 is negative 5. So the y-intercept is negative 5, and the slope is 3. So which function does that for us? It looks like it's going to be answer choice F. Number 28. Now we want to determine the equation of a line given its graph. Now if we look at all of the answer choices, what do you notice about all of the answer choices? They are all in slope-intercept form. Fantastic. Something else you'll notice is that all of the y-intercepts are negative 7. So that is not a possible way to differentiate among the answer choices. So let's try to write the equation of this line. So first thing we see, the y-intercept is indeed negative 7. Now let's try to determine the slope. So to find out what the slope is, we need to identify another point that we know is on the line. Well, it looks like this point is on the line. This point is probably on the line. And this point. Okay? So all 4 of those points are on the line. Now we need to find the slope of this line. Okay? Now remember, to find the slope, we need to pick 2 points on the line and figure out how much vertical change is there in between the 2 points, and then how much horizontal change is there between the 2 points. Now the vertical change, you'll notice that the graph goes down by 3 units, and the horizontal change is positive 4. So that must mean that the slope of the line is equal to negative 3 over positive 4, right? Because it's rise over run. Negative 3 over 4. Now, which of these equations has a slope of negative 3/4? Looks like answer choice J. And of course, J also has the y-intercept of negative 7. Number 29. In this problem, we need to write a function that represents this situation. The answer choice is going to be B. That's the correct answer. Do you see why? Well, the $1,200 is the initial payment, and then each month we add $258 to that payment, which means that 258 is going to be multiplying n. And then this is the amount that Marta has paid after n months, and we want that to equal the total value of the car, $12,294. So that's why the equation is set equal to that number. And of course, if we solve this equation, which we don't have to for this, but if we solved it for n, we would find how many months it would take to finish paying off the car. Number 30. So we are given a graph that represents some aspect of the motion of a train over time, and we have 4 different possible things that this graph could represent. Okay. Now, let's try to graph what each of these would look like. So if we were to graph the speed of a train as it decreases its rate of acceleration, so speed over time, let's see what that looks like for this. So it's decreasing its rate of acceleration, which means that, well, if the train had a constant acceleration, it would look like that. It would be a straight line, right? The speed is increasing at a constant rate. But that's not what's happening for f here. For f, the graph is going to look like this, right? The graph is kind of curving downward because the acceleration is decreasing. Let's try to graph g. So g is again speed versus time. Now the speed of this train in g, as it slows down when approaching the station, that means it could look like this, for example. So the speed is decreasing, right, because it's slowing down. And eventually the speed will become 0 when it reaches the train station. So that's one possible way to graph g. How about h? H, instead of having speed as the y, we now have distance. So distance over time. So the distance of a train from a station as it departed, as it accelerates. Let's see, it's kind of hard to see what h looks like, but let's do j. Distance and time. J, the distance of a train from a station as it approaches at a constant speed. So that means that the graph is going to look like this as well. So these two graphs both look the same, but they represent very different situations because the y variable is different, speed and distance. Okay, you see why j, the graph looks like this. It's a straight line with negative slope. Okay, so that means that, well, none of the 3 graphs that I drew look like the one up here. So it turns out that h will have a graph that looks like this. So it's a half of a parabola that is kind of curving upward. Okay, so h is the correct answer choice. So please make sure that you can convince yourself that h is correct. Number 31, which graph best represents the solution to this system of linear inequalities? Now the first thing that you should notice is that neither of these inequalities are written in slope-intercept form. So it's kind of hard to picture what their graphs look like, right? Because all of these inequalities are drawn as lines, right? The boundaries between them are lines. So the first thing we should do is write both of these in slope-intercept form. Well, x minus y is less than 0. So how do we get it to say y on one side? Well, one thing we can do is subtract x from both sides. So negative y is less than negative x. Well, how do we get just y on one side? Well, in order to do that, we need to divide both sides by -1. Right? That will take off the minus sign right here, and will leave us with y and positive x. But do you remember, what do you do? When you multiply or divide both sides by a negative number, you have to flip the direction of the sign. So y is greater than x. Now let's do the same exact thing to the second inequality. First thing would be to add 6x. So 3y is greater than or equal to 6x. And then finally divide both sides by 3. So y is greater than or equal to 2x. Notice that I did not flip the direction of the sign because I'm dividing by a positive. So, which graph has these two boundary lines? Well, let's see. Like in the graph A, this line right here is y equals 2x. This line is y equals x. So we want to find the graph that is shaded above this line and also above this line. Does that make sense? Because both of these signs are greater than or equal to sign. So which graph does that for us? Which graph shades above both lines? Well, it looks like the correct answer choice is, well, it could be C or D, but what's the difference between C and D? The difference is that one of the lines is solid and the other line is dashed. Okay? In D, this one is dashed, this one is solid. Well, crud. How do we choose between those two? Well, remember that if you have a bar beneath the inequality sign, that means this is going to be solid and this is going to be dashed. So we want, let's see, we want this line to be dashed, this line to be solid. Well, that's not true for C, but it is true for D. Okay? So we are done with that problem. Number 32. This is another example of a problem that will not actually be on the EOC, but I'm not going to be mean and just let it hang out there. The correct answer choice should be F. Okay? If you don't quite understand why, that's alright. You won't see a problem like this. Number 33. So we are given an equation, a linear equation, and 4 possible graphs that it could match with. We want to know which graph goes with this equation. First thing you should notice is that the equation is not in slope-intercept form. It is in standard form. That means that it's kind of hard to visualize what this graph looks like. But we can transform this equation into slope-intercept form pretty easily, I hope. Remember, slope-intercept form says y equals. So, in order to get this equation to say y equals, first thing, we need to move the 5x over to the right side. We do that by subtracting 5x. So negative 3y, remember, do not lose that negative sign, is equal to negative 5x plus 12. And then finally we divide by negative 3. Remember to divide every term by negative 3. So y is equal to 5/3 x. Notice this has become positive minus 4. So we know that the y-intercept of the graph that we want is negative 4. Let's see. So that immediately marks out B and D, right? Because the y-intercepts of both of these are positive 4. Now the slope of the graph that we want is positive 5/3. Well, the only graph of A and C that has a slope of positive 5/3 is A. Do you see that? Y-intercept is negative 4. Go up 5 and then go over 3. So the slope of this guy is positive 5/3. So the correct answer choice is A. Number 34 gives us a graph, a scatter plot, and we are asked to extrapolate to the year 2024. So we want to kind of extend the that was not a straight line. There's that. Extend the x-axis out and figure out what will be the movie price up here when the year is 2024? Well, let's try to figure out a way to do this a little bit more exactly. One nice thing is that the possible answer choices are kind of spread out, right? It's not like we have to choose between 9.4 and 9.43. That would be ridiculous. But how are we going to do this? First thing I would recommend is try to make sense of the scale that they have down here. Notice that this is number of years since 1969, which means that 0 corresponds to 1969, 10 corresponds to 1979, 1989, 1999, 2009, which means that 2019 would be right here, and 2029 would be right here. So we want to know about the year 2024, which is going to be right smack in the middle here. So let's extend that line upward. Okay. All right, so I extended the line upward from the year 2024. So that means that if we kind of follow the trend of the points upward, it looks like in the year 2024 we will be somewhere in this area. Well, what value does that correspond to over here? Well, 7, 8, and then 9-ish. So it looks like the price of a movie ticket is going to be about $9-ish in 2024. So the closest answer choice there, H, right? H is closest to being 9. All right, number 35, last problem that we're going to do in this video. Which ordered pair represents a solution for this system of equations? Well, first thing you might notice is each of these x and y pairs satisfy the second equation. You see that? If you add the x and the y of any pair, they add up to 12. So the second equation is not going to help us differentiate between the correct and incorrect answer choices. But in order to find the correct answer choice, I would recommend working backwards. Simply take a possible answer choice and stick it into the equation, the first equation, and see if it makes it true, right? Because we already know that they make the second equation true just by looking. So if we test answer choice A, let's see, 2.5 times 3 plus 7.5 times 9 equals 75. You see that? So answer choice A does make the first equation true. So A must be correct, all right? Because like we said, it already makes the second equation true. 3 plus 9 equals 12. And you can see that I already tested answer choice B, and it came out to be 45. So answer choice B is not correct, all right? But that is how you would test to see if these ordered pairs are solutions to the system or not. All right, that's it. We're done with this video, finally. Hope that it was helpful for you.